Welcome everybody to Speaker Series. We have a very special guest tonight, Dr. Kaeli Swift, going to speak about corvids, crows, jays, ravens, etc., magpies. And she's coming to us from University of Washington. We'll introduce her in a moment, but I wanted to say a couple things about Audubon. During COVID, of course, we had to shut down, pause all of our field trips, but we're resuming those very, very soon. I had a field trip today. We had one the other last week. We have one tomorrow. So gradually the field trips are coming back. Our field trip leaders are energized and ready to go. So things are pretty darn exciting at Audubon right now. And we've been busy all summer, actually. Our new Avocet newsletter just came out recently. For the summer issue. It has a lot of good stuff, a lot of fun stuff in it. We have another one coming out next month. We're going to be doing some classes in August and September. First one's going to be on shorebird migration. The second one's going to be on warblers of fall. So these will be remote classes, and we'll take signups for those in the next week or so. I think I'm still building the shorebird class, and then after that I'll start on the warbler class. But I'm really excited about the material, and I'm hoping that it'll prepare people for the upcoming migration season. But anyway, enough about the chapter. Carolyn Knight's right here. She's the Education and Outreach Manager, and you met Barry already. And Dr. Swift is right there as well. So before I started, I wanted just to say that Dr. Swift's work on crows and ravens and jays is inspiring. It's incredibly interesting what she's articulated about their lifestyles and their intelligence. And just as a personal anecdote, years ago when I was in Singapore, there was a corvid there called the house crow. And I was walking through the Central Park in Singapore, and I saw the crows gathering on the light posts over the road. And they would routinely go down to a little puddle by the side of the road and pick up a squirming frog from the puddle, which would immediately inflate itself into a hard ball that could not be swallowed. So the crows grabbed the ball as much as they could, get their beak around it, and they flew up to the light post over the intersection. And then just before a vehicle drove by, and they seemed to have a special interest in large trucks, just before a truck rolled through the intersection, the crow would drop the inflated frog, which basically looks like a ball at this point, drop it onto the road. It would bounce a little bit, and then the truck would roll over it, and you'd hear this horrible squishy pop as the truck rolled over the frog. Then, only when it was safe did the crow fly down to the intersection and pick up the flattened frog, which had been nicely tenderized by the truck, and then it could eat it, then it could swallow it. And I thought, well, wow, that takes a few kind of leaps of faith to get through that thinking process. And I thought that is one smart bird. And we see it all the time around here with our various crows, jays, magpies, etc. They store food. They do wonderful things that definitely suggest advanced intelligence. And I think that's why they're so charismatic and why I'm so fascinated by them. But before we welcome Dr. Smith and Dr. Swift, sorry, I wanted to pose a question to people in the audience. How many corvid species do you think we have in California? And then the second part of that question is, how many corvid species do you think are on the official list of Santa Clara County? So we can take a look at the answers after that. But Dr. Swift, I want to welcome you. Very excited to have this caliber of conversation for our speaker series. I've been looking forward to it for months. And so is Carolyn and everybody else who signed up. So I just want to thank you so much for taking time out of your schedule to be with us tonight and help us learn more about why corvids are so exciting and what you've learned about them. So take it away.
Well, thank you so much for that introduction. I'm going to give me just a minute to share my screen, and I am so excited to talk to you all about crows. It's one of my favorite things, and I'm going to just get right to it. Just make sure, because I have a tendency to learn when I start talking about crows that just kind of keep going. So Carolyn or Matthew, feel free if at some point you're like, give me the little signal and I can wrap it up. So I want to just get right into it. So the first thing I want to address, and I know I'm talking to birders, but this is a question that can plague beginning birders, even more advanced birders, and that is, there's a lot of these sort of general crow-ish birds that superficially look really similar. So are they different, and what does that mean, and how do we tell them apart? And most specifically in some place like California, that question is going to pertain to common ravens and American crows. And even though they look very similar, they are two distinct species. And in fact, there are, I'll leave you to think about Matthew's specific question, but globally, there are 45 different species of crows or ravens around the world. We have a variety here in the United States, but the ones that you're most likely to encounter are the common raven and the American crow. They're both all black, but one of the biggest differences, so to speak, is size. So ravens are about 2.5 times the size of a crow. Now that feels really obvious and like a really good field mark, but if you're not used to looking at these birds, or they're not next to each other, or if you see them in a photograph, it can often be difficult to judge scale. So we'll talk about some other ways to distinguish them in just a minute. But in terms of their sort of natural history, their ecology, ravens tend to be more wildland birds. They can certainly do very well in urban centers. There's a very robust breeding population in San Francisco and in downtown LA. But oftentimes across the country, those places are already strongholds for crows. And so they keep the ravens from moving in. Ravens are also more carrion specialists than crows are, meaning they eat more dead animals. Crows are much more adapted to eat insects and garbage. Ravens will happily visit the local dump, but they're definitely more adapted to living far away from people, out in the middle of nowhere, eating dead animals, than crows are. So those are some of the kind of basic distinctions between these birds. So I know it's most of you, I assume, have eaten dinner. We're all at home, so we're like in our pajamas, we're very cozy, and you might sort of be like nestling into your chair. So I want to give a little quiz, just keep everybody high energy and on their toes. So I play this game called Crow or No once a week on social media. I'm taking a little hiatus now, but I will return to it soon. And the premise of this game is very simple. There are, like I said, there's lots of sort of crow-like blackbirds or other kinds of crows and ravens in the corvus genus. It's the genus that houses those species that look similar. And there's a lot of other kind of birds that seem to have sort of corvid-like features. And so I noticed many years ago that I was often seeing photographs misidentified, particularly on Facebook in birding communities or sort of crow subculture communities. And it seemed like people were really struggling to really identify crows versus ravens, or this kind of crow from another. And so that is where the idea for this game took hold. And it's a very simple premise. I'm going to show you 4 pictures, and I'm just going to have you think about if you think the bird in the picture is a crow, meaning it has the word crow in its common name, so what you would find in a field guide, or not. And that's it. That's all you have to decide. And feel free to put your answer in the comments or use the hand wave if you want to vote publicly. So here's our first bird. Number 1. Give you just a minute to give this one a little think. Number 2. Oh, my thing's not advancing. It's our second challenger. Number 3. And finally, number 4. This game is definitely more fun to play with a live audience, but I'm going to trust that everyone's at home really getting into what they think with strong opinions. So I won't be able to have the joy of assessing what the most common answer was. but that's okay. So for our first one, people thought it was either a crow or not. The question was, who was right? And the answer is, this is a crow. This is like really, okay. I know, that was a tough one to start off with, because dang, that is a tricky bird. It's got that big bill. It's very raven-like in its features, but this is the large-billed crow, which is native basically throughout Asia. It used to be called the jungle crow, but then we split it. And so now we have the large-billed crow, which is the most common crow in Japan, for example, though there are other species there too. But it's a very raven-like bird. And actually, I will take this moment, because this is a question I rarely get asked, but people always seem to enjoy learning the answer to. Actually, no, I will pause there. We'll finish the game and then I'll get to it. So first one, crow. If you guessed crow, nicely done. Second bird, no crow. That is a grackle. So this one has easier tells. You can see that iris is yellow. There's only one crow species that has a yellow iris, and it only has it for this very brief window of time when it's a juvenile, and it's one of the Caribbean crows. By and large, if you see yellow eyes, not a corvid. The most reliable tell, though, is if you look at the top of this bill and compare that to this one down here. Do you see how the bill is totally bare up until the point that it meets the face? Versus this bird down here has these feathers that go across its nares like a little mustache. So this feature is ubiquitous across all of the crows and ravens. But birds like grackles, blackbirds, carawongs, butcherbirds, so the Australian magpie, for example, is not a corvid. You can tell because they lack those little mustache feathers right there called rictal bristles. Bird number 3, common raven. This was also a heartless photo that I have tested you with, because look at this angle. But on the other hand, like, this is how we often see birds, right? They're kind of doing something weird and you take the picture and it's kind of bad lighting on a weird angle. But if you look right here, you can see some pretty heavy texturing on the throat. And that feature is called hackles, and that is unique to common ravens relative to the crow species we have here in the United States. Likewise, using that same logic, you have the mustache here, so you know this is indeed a corvid and a crow or a raven. But if you look at the throat, it's very smooth. You don't see this kind of beard-like texturing. And so that is an American crow. Some more physical differences. So again, this is just pointing out the difference in that texturing in the throat. Here, the raven has this really heavy beard-like texturing, where crows, the feathers look really fine, almost hair-like. The other feature that's really distinctive and useful when they're in flight, not so useful when they're perched, but really useful in flight, is the shape of the tail. So this one has a wedge or a diamond-shaped tail, and this one is more squared off. And again, that's going to be most helpful when they're in flight. Returning to the item I was going to share a little bit earlier, some people may be like, okay, this is really helpful, so I understand American crows versus common ravens. But say you were to go to a remote island no one had ever been to, and you found a corvus bird, how would you know to name it a crow or a raven? And the answer is you don't. That's totally arbitrary. There's no one thing that actually makes it a crow or raven. Typically, if it's larger, we give it the raven title. But like there's lots of instances where we've, I think, in my opinion, done a poor job. Like the Hawaiian crow, very big. We should probably call it the Hawaiian raven. The pied crow has really heavy texturing right here, just like the raven. So we might call that a pied raven instead. And so is there actually any difference between crows and ravens when it comes to how we name them? The answer is no. If any of you are familiar with Bird and Moon comics, Rosemary Moscow is the illustrator. She does these fantastic comments about birds, other kinds of wildlife. And her and I collaborated to make this, I call it the adorable guide to distinguishing crows and ravens. And I encourage you to look for this, save it to your phone, share it with your birder friends. It just gives you a few of those really key tips, including the throat feathers, tail shape, pointing out that the calls are different. And then this little feature, which is really fun, which is some of the difference in their flight behavior. So I imagine many of you have had the pleasure of watching ravens, and you probably, if you've spent time doing that, you've noticed how often they do these barrel rolls. Now, if there's any aeronautics folks in the audiences, I'm sorry I called it a barrel roll. I know it's an airlion roll, but when I say that without context, nobody knows what I mean. So I just call it a barrel roll. You'll notice they do these, right? It's really fun to watch them do that. And the reason they do it is that's actually one of the ways that they delineate their territory. So it's actually a territorial display. It's not just for fun. Crows are physically capable of that behavior, but because they don't use it in any kind of signaling for signaling purposes, they don't do it as often. So one of my favorite features of crows, and the thing that I most hope you as audience members get out of this talk, is that while crows are incredibly widespread in our urban areas, they're very ubiquitous, they can easily kind of fade into the background or even be perceived as nuisances or pets because of the ways that they interact with other birds in the area. I really want to compel you, and hope that I do so by the end of this talk, to really think of them as wonderful opportunities for bird watching and naturalism, and not just these sort of garbage birds that linger in the background. There's a variety of reasons for that, which we'll get into, having to do with just the amazing uniqueness of their behavior, but also just appreciating their natural role in the environment. These are not introduced birds. They have moved and adapted with us as people, but they play a very important role in their ecosystems. And that sometimes is a role as a predator, and that can be really hard when you've been watching that robin's nest. You watch them build it, they laid, they've been tending, you've been really rooting for those chicks, and then you got crows coming in and depredating them. That can feel really bad, and I understand that. But that is a normal part of the breeding system. That's why robins lay a lot of eggs and they re-nest many times, or any other birds. And so if you can kind of create space to become okay with those kinds of predation events, and give yourself space to get to know these birds, I think that you'll find that they're really unique and wonderful opportunities to engage in wildlife that other birds and really other kinds of wildlife don't offer. So there are some key features of their life history that enable the kind of relationship that I'm going to be talking about. So one is that they are synanthropes. And what that means is that, there's a lot of backyard birds like towhees and juncos and chickadees that have, figured out how to live among us, right? They enjoy our feeders, they can nest in the backyards that we create, and they're making it work for themselves. But synanthropes like crows, they don't just kind of make it work. They really seek out the environments that we create, and they really almost exclusively live in those kinds of environments. And that's why we often see such big populations of crows in urban areas. And the reason for that, the kinds of things they're seeking, is they like the same kinds of landscapes that we do. Unlike ravens, American crows, they don't want to be out in the middle of the woods way away from things. They like it when we urban sprawl, right? When we chop those wood, what's the word I'm looking for? Not necessarily old growth, but when we chop down those intact swaths of forest to put in neighborhoods, because they don't need a lot of trees. They like a few though, and we do too, so that they can put their nests in them. They're also one of the few birds that can utilize the industrial lawn. If there's one thing I can compel you to do as a birder, as somebody who cares about nature, it is to maybe slowly shrink your lawn, because it's one of the really the banes on wildlife, because there's just so little anybody gets out of that. But crows, they like it because crows, about 40% of their diet is insects. And so if you ever see crows kind of like working transects across your lawn or a local park, that's what they're doing, is they're actually looking for insects in the grass. And then the last feature, the other big component of their diet, is that they really like that we just roll out barrels of garbage on a weekly basis, seemingly just for them. And then sometimes we do them one better and we just throw it right on the ground for them. So that combination of creating this really manageable breeding environment, and then providing a lot of food, and then in some ways also walking back the predation pressure from other kinds of predator birds that maybe don't do as well in those environments, all works really well for crows. So they're everywhere, and they're very accessible. And that's wonderful, because birding really should be accessible to everybody, but there are a whole variety of reasons why that's not always the case. And so I love that for crows and about crows that kind of no matter, even if you, whether you live in a beautiful large property with lots of acreage and woods, or you live in an apartment complex in the middle of an industrial area, you may very well have these birds to watch and enjoy. And you can do so for a long time because they can live anywhere between 14 and 17 years old. That's not uncommon. Right now is the breeding season, so we've got young crows out. About half of them will die before the year is done. Those first couple of years are very tricky, but if they can survive to sexual maturity, which hits about between 2 and 3 years old, then they do pretty well for themselves. So survivorship can be as high as 80% annually. And so if you start paying attention to these crows, you might be paying attention to the same individuals for many, many years. And then the last component that facilitates that is that crows form permanent pair bonds. So that means they mate for life. And they are territorial, particularly in the breeding season, which means that they establish these, breeding areas, and they defend those breeding areas from other crows, though that does differ a little bit geographically. Some populations are very chill and other populations are pretty aggressive. But if you see 2 crows on a light post outside of your house every day, that's probably a pair, and it's probably going to be the same pair for potentially over the next decade. And that's the thing about crows that I think is so special, is once you start watching them, unlike the joy of seeing house finches and chickadees and, counting all the different birds that come to your feeder where you're like, that's a chickadee, that's cool, I love chickadees. You can be like, that's Joe the crow. And last year, Joe had 4 kids and one of them got killed by a cat, and I was really sad, but the other 3 seemed to make it. And now he's back, and his partner she just hurt her foot, so she's limping around. I just saw Joe try and feed her, and there's just this amazing intimacy that is possible with these birds that we just don't get really with most of the other birds that we share space with. We already talked about diet. They're of course omnivores, they'll eat a variety of things. One thing that they like to do with their food is dip it in water and soak it. So if any of you have bird baths, you may already know this because the crows might be bringing things and depositing them in your bird bath. If that's true, I'm sorry. And no, I don't have any advice for you. It's just that's one of the things that's one of the reasons you provide water is for that. And it is good motivation to clean your bird bath every day, which we should be doing anyway. That's best practice. So I told you that they form permanent pair bonds, but there's a fun little quirk to their pair bonding, which is that they are socially monogamous. So they maintain those pair bonds year round. But when we do genetic testing on the offspring, we find that males are only siring offspring about 80% of the time. That's based on a pretty limited data set, but that is the trend that we have seen so far. And so that suggests that there are other things going on. And the reality is that's very common across birds. Total genetic monogamy is incredibly rare among wildlife and among birds, even though birds, relative to most other kinds of animals, do pair bond and are monogamous and have shared offspring rearing. And then the last feature that I think is really relatable for us as people is that crows engage in cooperative breeding, which means that once their young reach independence, some of them are going to go disperse and may never ever come around or see mom and dad ever again, but some of them are going to stick around, or they may leave and actually come back, and they will stay on their natal territory, meaning where they were hatched, and they will offer some assistance in rearing subsequent broods, and they may offer some assistance in territory defense or food provisioning, but it's not a lot. They don't seem to do much, and so there's this ongoing, really curious question of what's in it for these adults that they put up with these freeloaders, essentially, because it's a great deal for the young birds. And but the benefit it has to the parents is still yet to be determined. So that's a really interesting area of study. All right, how many people have had this experience or know someone who has? You are minding your own business, walking the sidewalk, and all of a sudden you get the swoop, the back of the head swoop. If you have, you'll know that it's very scary. It's also, this is the time of year where it is really peaking. And in some cities like Vancouver, BC, for example, actually make maps to try and help people identify where the swoop spots are, because it can become really intense. And there are a variety of reasons that crows may swoop people, but when it happens in the summer, it is almost exclusively related to young. So we often think of bird nests as being very cozy places, right? I think because bird nests are associated with bird houses, and the word house, we think of as places of safety and security. But the reality is for open cup nesting style birds, and what that means is, the traditional bird nest that I think most of us think of when we think of a bird nest, are actually incredibly dangerous places to be. And so birds are very compelled to leave that nest as quickly as possible. And oftentimes that means that they leave the nest before they can fly. And that's really common in corvids. And that includes jays and crows, all those kinds of birds. And so there's this period of time where those young are on the ground. They're very vulnerable because they can't fly. They're also very vulnerable because they're incredibly naive. They're just getting their grasp of the world. So as you can imagine, it's a very stressful time for parents. And they have very little recourse when it comes to seeing a human, which is an incredibly large, potentially powerful and dangerous animal approaching their young. And even though generally speaking, most people are not paying any attention, they have no mission to harm that baby. They probably don't even know that it's there. The parents, it is literally exclusively their job to pay attention to that and to try and protect their young. And swooping is really the only means they have to do that. So if this is becoming a problem where you work or live, or you know someone for whom that is the case, the simplest thing that you can do is just start carrying an umbrella. Think of it as a different kind of rainy season, and as a really small gesture that you can make to become more accommodating for wildlife and really embrace the idea that we share space with animals, right? They're not coming in to our space. We're not sort of figuring out how to be generous. This should really be an action, not of generosity, but of just recognizing community and expanding our definitions of community to include non-human animals and non-human parents. So carry an umbrella, and then that's it. That's problem solved. And come about August, the behavior will stop. So it's seasonally limited, and hopefully it's not too much trouble. Since part of the problem is that people don't know why this is happening, I think one of the things that's really helpful at this time of year is to teach people how to identify baby crows. Because one thing that's really common is folks, when they think of baby birds, they think of something really small and obviously different. But by the time they fledge, most babies, while the plumage can be quite distinct in some species, size-wise, they're pretty much the same size as the adults. And because with crows, the plumage isn't any different, they're just black, it can be very hard to know if you're looking at a baby. But that can then help you kind of contextualize and understand why this thing is happening to you right now. So there are some good features to look for. One is for the lack of melanization, so the black pigment in the beak and legs. That's not going to last too long, only about a week after they've fledged, kind of at most. But if you see pink bills, pink legs, that's a baby. What will persist through the summer, though, is the pink right here in the corner of the mouth, and that's called the gape. And that basically, that will seal up eventually, but for now, they can open that, and that just facilitates them opening really big and wide so that parents can feed them. So look for those mouth corners. If you see any evidence of pink, or when they open their mouths, if you see bright pink in the interior instead of black, it is a baby. And then eye color. So crows have blue eyes for the first 3 months after they hatch, and then they will turn brown like the adults do. There's also some proportional differences, kind of short tail. And then like all birds, this first round of feathers are crappy. They have to grow them really fast, right? Because they're trying to get out of the nest as quickly as they can. So because these feathers grow so much faster than they will every subsequent molt, they're of very poor quality. And so they lack that nice gloss, that nice, beautiful iridescence that the adults will have. So now we've kind of got our life history covered. Now I want to talk about the really fun stuff. So this is the kind of stuff that got me into crows, and specifically this crow and this video. So the context here is, this is Betty, and Betty is a really cool crow because she's a New Caledonian crow. And New Caledonia is an island off the coast of New Zealand where there are no woodpeckers. So there's this whole food niche where there's, big tasty grubs and insects hiding under the bark of trees that wasn't being exploited by another species. There wasn't a specialist for it. So crows, being the omnivores and problem solvers they are, they were like, well, we want to get in there and get those tasty bugs. But they don't have the kind of physiology that would protect them from brain injury the way that woodpeckers do. So they can't just like go hammering in there. So they needed a different solution. So New Caledonian crows are the only other animal, non-human animal besides chimpanzees that make tools. Only about 1% of all animals use tools, so that's already very rare. But creating tools is a humongous cognitive leap. It's much more challenging. So New Caledonian crows, and they make similar tools to chimpanzees because it's the same idea, right? They're sticking it into wood and they're trying to compel these insects out so that they can eat them. But the tricky thing is that when we're trying to ask questions about intelligence and cognition is sometimes animals can perform what seem like really sophisticated actions, even though they don't understand them. So these researchers wanted to know, how much does Betty understand about the tools that she's using and why they work? So she was given the task, I'll start this playing. She has this clear cylinder, and at the bottom of it is a little bucket of food, and she wants the food, and she's been given a straight piece of wire and a hook. And the question is, will she choose the correct tool for the job? Does she understand it? Unfortunately, Betty's cage mate, who's also part of this experiment, and this is the first time she's been given this, got the hook, and then it flew away with it. And it said, I don't want to participate in this. So Betty obviously is hungry. She has a straight piece of wire. The researchers are frustrated because it seems the experiment is ruined. And, I'm sure they're just kind of lamenting why they picked this job where animals, all right, okay. So actually we learned something way cooler than what we were testing, because not only did Betty choose the correct tool, which was a hook, but she spontaneously made it, which is like a whole different, amazing thing. And I will tell you right now, if you were not delighted by this, then you can salvage the rest of your evening by logging off, because the talk doesn't get any better than this. This is kind of like just peak, like, oh my gosh, awesome crow stuff. And when we first saw this, we were just like, wow, this is amazing. Now we know that New Caledonian crows actually make hooks routinely. It's part of their toolkit. And they do that by snapping off twigs, and then they break off all of the auxiliary branches they don't want. And then they kind of bend the last one until it's the right shape. So it's a slightly less exciting in that it wasn't a completely spontaneous behavior, but she was crafting it out of a material she'd never been introduced to before. So that's still pretty freaking awesome. So at this point, it's very fair to kind of say, whoa, okay, intelligence. What does that mean? How do you measure that in an animal? You are a human, you see things through a human lens. How can you possibly have the hubris to try and evaluate intelligence in other beings? And those are totally good, reasonable questions. And the answer is that we're probably mucking it up a little bit, but we're trying our best by identifying a framework where we have been able to show that there are some skills that cannot be achieved through trial and error learning or instinct. They have to be achieved through cognition. And there's kind of 4 main parts of that toolkit that we've identified. So one is causal reasoning, cause and effect. And we actually, Matthew kind of gave us a great example of this, right? With dropping the frog in front of the car. And his observations seemed to suggest that the crows understood the relationship there between putting it in front of a car and it getting flattened. This gull, on the other hand, you can see them, if you go to the coast, you can see them collect clams and they'll fly them up in the air and they drop them. And you're like, well, that's really smart. Good job, gull. Like, that clearly understands something. But when we start to take data on that and notice where they drop them, we often fail to find trends in terms of gulls being able to reliably drop them on the correct surfaces. So they'll drop them over water or over sand just as often as they get it right and drop it over rocks or asphalt. And that's because while they have learned that if they fly it up high and drop it, they often get food, they don't actually understand why it works. Crows, on the other hand, will really reliably perform that action over the correct surface because they understand the relationship between what they did and the outcome. The next feature is imagination. We take that for granted as people because we do it all the time. That's actually very hard to kind of use your mind's eye to picture something that's not happening in front of you. Flexibility is the next one. There's a lot of really important behaviors that are executed just by instinct. But one of the challenges is those behaviors can't be modified. So a good example of this is gray-lag geese nest on the ground. And, as the female is getting up to sort of fuss with herself or whatever, sometimes she accidentally kicks an egg out of place and out of the nest. And so she'll roll that egg back in the nest. And that's really important because if she doesn't do that, that chick will die. The constraint intellectually, though, is, as it turns out, you can put anything outside of a gray-lag goose nest and they'll roll it back in. You can put a rock or a golf ball or an orange and she'll just be like, oh, okie dokie, get that back in, right? Because for her, it's just seeing a stimulus and that produces a very specific response. But we would be like, well, that's an orange. I don't have to incubate that. That's not a baby, right? Because we can sort of change our behavior with new information. And we see evidence of that in corvids. And then the last one is prospection, which is the ability to think in the past, take past experiences and then use that to think ahead. It's essentially mental time travel. So I want to show you some examples of how we have identified these behaviors in the corvids. And we're going to start with, and actually I saw somebody in the chat earlier mention Aesop's Fable. And I don't know if you knew when you brought that up that we've actually tested that specific fable in crows already. But if you're not familiar with this, Aesop's Fable of the crow in the picture is the story of a very thirsty crow, saw this pitcher of water, but the water level was too low for it to reach. So it gathered a bunch of stones and it dropped it in, and then the water, of course, rose and it was able to drink. And so that is a great example of an understanding of causal reasoning. And there was a group of researchers that looked at New Caledonian crows and said, all right, challenge accepted. Let's see if they can do this. So they sort of took that fable and then they adopted it into a variety of challenges. And the video will explain to you what those are. So in most all of these, you have a cylinder with water and a floating plate, and the crow is choosing to get out. Here you have solid with hollow objects, and it chooses the right one. And so here's our goal test, water versus sand. Dropping a rock and sand is actually different. So will they more than would be expected by chance? And then here's a thin tube, a wide tube. Comes to develop a lot faster, so it's supposed to go into, but it doesn't. They don't do that reliably. They're not necessarily they don't understand it. And then this one is called the hidden connections test. This is a more challenging one. And so what's going on here is you have three tubes of water, two wide mouth ones on the outside, and a center tube that has a narrow opening, and that's where the food is. So this opening is too narrow for the crow to drop any of these rocks into. And what you can't see as the viewer, and what the crow can't see, is that this red tube is actually a U. It's connected to the center one. So if you drop a rock in the red tube, the water level will also rise here. And the question is, with practice, will the crow figure that out well enough to then do it reliably? And the answer is no. No matter how much practice you them have, they never get better at using like not able. And before we sort of are right off our crows, like, they didn't get that connection test. Or what are they? I guess not as smart as we think they are. Kind of we don't really start performing all that well at those kinds of hidden connections tests until we're 8. So that's actually very impressive. And that's where if you see headlines like crows are as smart as an 8-year-old kid, those are the kinds of studies that language is based off. Obviously, there's a lot that's, a little bit myopic way to interpret it, but from very particular developmental standpoints, it is technically true. One of my favorite things about these birds is their sociality and the way that we've been able to utilize that to try and understand things like their level of consciousness and theory of mind. And ravens have been common ravens have been the main source of studies where we've looked at that. And these birds just are so incredibly complex. And ravens have really, house of cards level political lives. And one example of that is ravens have this incredibly hierarchical social system. And birds at the top, this is going to sound very familiar to folks, birds in positions of power, they like to maintain those positions of power. They don't want to give them up. So ravens are constantly kind of dominant pairs are constantly looking around, assessing potential competitors. And something we've been able to document that they do is if they've assessed 2 individuals as being pretty, potential competitors, if they see those 2 individuals getting together and bonding, they will physically go in there and disrupt that relationship building, right? Because if that relationship were to form, that new pair might be a real threat to their position. And so they're engaged in this level of sort of planning and insight that is really amazing. The other thing that we've more recently been able to demonstrate with ravens is a hallmark of empathy. So we're not quite ready to say that non-human animals have empathy. And that's just really mostly a product of scientists being incredibly conservative and not wanting to say anything unless we have really discrete empirical evidence. But we can say that they express emotion contagion, which is essentially what empathy is, right? Empathy is about being able to say, my friend had a bad day at work and now I feel bad. I'm taking on that emotional state that they're experiencing. And there was a really cool study that demonstrated that utilized an observer demonstrator paradigm, meaning they had a demonstrator raven was in a room, and then they had a separated observer raven on the other side of a glass wall, right? So they could look in, and the demonstrator raven would be given a box. And in half the cases, there was something really exciting in the box, like mealworms or something great. And the demonstrator raven would look in and would get all excited. And the observer raven, they couldn't see in the box. They could just see the demonstrator's reaction to it. And in the other half of the experiments, the demonstrator got it's something lame, like a grape. And they just weren't that excited about. And then the question was, if the observer was then given their own box, how do they react? And they found that if those observers had seen the demonstrator get really excited, they really quickly looked in the box. But if they saw the demonstrator not be so jazzed about it, then they didn't really have any interest in looking at the box, right? So they were clearly kind of looking at those reactions and then adopting that state, and that informed their behavior. And so that's really, it's not officially empathy, but it is basically the first kind of hallmark of it. And now I want to talk about what I specifically studied in graduate school, which was their funeral behaviors. And so what I mean by that is when a dead crow or a dead scrub jay or a dead raven is discovered by other members of its species, most typically what we see happen is that the discovering bird will alarm call they'll make that harsh caw sound, and that attracts other crows to the area, and they'll form this raucous mob, and they'll be sitting in the trees, and maybe they'll be quiet, and maybe they'll be really loud, and then after about 20 minutes or so, they'll all kind of leave. And this was a very well-known behavior to human beings. So I did not contribute the identification of this behavior to humanity or to science. In fact, there is references to the way that these birds perceive death in many, many different texts, including ancient religious texts like the Quran, for example. So humans as a group have been very familiar with this. The question I wanted to ask was kind of getting into asking more specific questions about what and why. And so just to give a little more context, crows are certainly not alone in their interest in their dead. We see it manifest in a variety of other animals, including cetaceans. So here's a dolphin with a calf draped around, a dead calf draped around their dorsal fin. Here's a gorilla carrying a dead infant. And then of course, elephants are really well known for this behavior. They are very attracted to their dead, even once they've been reduced to bones. And while these animals probably get the most sort of exposure in the media, it's actually this last group, the social insects, that we know the most about. And so these are all colony nesting insects. Hygiene, colony hygiene is very important. And so these animals have really, really predictable behaviors towards their dead. And we've been able to do a lot of studies. And so we can kind of group animals and how they respond to their dead in two groups. So there's the ones that we've done a lot of experiments on that have really predictable behavior. So ants, termites, right? They'll grab corpses and they'll throw them out of the colony, or they'll wall them off, or they'll eat them. Rats will really reliably bury cage mates once they start to release decomposition odors. And then some birds, gulls, will just get out of an area if they see a dead gull. And then we have this other group where we have a lot of observations, but not a lot of experiments. And we find that they don't seem to do the same thing every time. They do a whole variety of different things. And that's made it really hard for us to sort of ascribe specific adaptive values to what they are doing. And corvids are kind of right in the middle, where they generally do what I described earlier, but sometimes they do other stuff like place objects on the body or be silent for a really long period of time, or any number of things. And so they offer a really nice opportunity to ask this question of how a non-human animal reacts to one of their dead. So I asked a couple of questions. I wanted to quantify how they respond, how many birds show up, how long they stick around, what kind of sounds they make. I wanted to ask, what is the adaptive value of their response? So there are a variety of ways we could explain why crows are interested in their dead. Some of those are testable questions, and some of them, like whether or not they're experiencing grief, are not. It doesn't mean that they're not important or possible answers. They're just not something that I can test. But something like, are they using dead crows as cues of danger? That I can test. And that is, in fact, what I tested. And I'll talk more about that in just a second. I asked what kinds of things they paid attention to in terms of context. So one way that we might explain why, in this one case, when chimpanzees came across a dead body, they ripped it up and then ate it. And then in this other case, they quietly groomed it for an hour, is maybe that different ages have different impacts on their behavior, or maybe sex, maybe how it died, right? So there might be issues of context that inform how animals respond. And then the last question was, what's actually going on in their brain when they're seeing a dead crow? Because there's only so much information we can get from just looking at how they respond. Maybe there's more that we can learn if we understand how their brain's actually processing it. So in that first question, I asked how and why do crows, do they respond to their dead? And I wanted to see, is this a cue of danger learning? And I wanted to ask that in the context of the place. So places they find dead crows, do they learn that those places are scary and they are more cautious in them, or maybe they avoid them? And then can they learn new predators, and specifically people? So the way that we tested this is I would start to feed a breeding pair over the course of 3 days in a specific spot. Then on the 4th day, we would have somebody wearing a mask come out and hold like an hors d'oeuvre plate, this dead crow. And then for the next 3 days, I would keep feeding them, because that gave me a kind of before and after comparison. Do we see that they stop coming after this event, or does it take them a lot longer to come, or is there no difference? And then after a week, we would have this same person come back, now not holding a dead crow, just kind of stand there like they were doing before, and we monitored how the crows reacted to them. So if you're wondering why we use these creepy masks, or how you could possibly answer this question, because of course crows would be terrified, because look at this. The answer is one, we had to utilize volunteers. We weren't able to pay technicians. And so that meant that the person who is there available to hold the crow on this day may not be the same person who's available a week later to come back. But if we have them wear a mask, it doesn't matter, because we can keep the face the same. And luckily, so far, crows have not seen Halloween enough to have the kind of connotation with masked people that we do. So they don't seem to get too freaked out by these masks, although if they're really exaggerated versions of human faces, that might aid in their ability to identify them. And so that's another reason why these masks are so creepy, is because they are not, caricatures in any way. They're very neutral. They're meant to look like you cut someone's face off and put it on your own, which we hate, but is good for this particular question. And so the answer is that crows paid attention to both. We saw a significant delay in how quickly they would come to the food in the days following an event like this. And we also saw that most birds learned the person and continued to harass them when they saw them again for the duration of the study. If you want to learn more about that, that was like a horrifically simplified version. There was actually a lot more that we tested. So if you like reading dry academic papers, you can find it on my blog. I also did some more popular science write-ups on it too. In terms of context, I wanted to ask, do crows pay attention to age? Because I shared with you at the beginning of the talk, young crows, like this blue-eyed fledgling, they're much more likely to get killed than adult crows. So if one of the things driving their interest is in cues of danger, then they should pay more attention to this than this, right? Because a dead kid doesn't necessarily tell you that much. They're getting killed by all kinds of things because they're naive and things that adult crows know better to avoid. But if a nice, healthy adult, if you find one of those dead, that means something pretty bad might be happening. So we did a second study where we would find breeding pairs, and now we don't have any masked people, we don't have any food. We would just put the dead crows on the sidewalk at a regulated distance away from the nest, and then I would take notes on how many birds showed up and how long the mob lasted, all those kinds of things. And we found that while in the wintertime, they respond really strongly to both groups. In the summertime, they almost exclusively respond to adults. And summertime is a much more constrained period because the birds are really busy, they got kids, they got a lot to worry about. And so we took that, we interpreted from that because that time of year is more constrained, they're only going to respond to the strongest, most threatening stimuli, and that's a dead adult. So it does seem like crows are actually paying attention to contextual features and then using that to determine how they'll respond. Now, in addition to that, I also learned something I was not expecting to doing that particular experiment. Because remember, in this one, there was no person there. It was just a dead crow on a sidewalk. So there wasn't anything to prevent or scare off the crows from coming close. And what we found is that in the spring, they come shockingly close. This is a breeding pair. I can't tell you which is the male and female, but this is the first mate. It's exploding, it's having an alarm attack. And then that's the second bird, it's partner. So if you don't know what it looks like when birds have sex, you do now, because it looks like that. So basically, to put it bluntly, we kind of had a sexy dead crow sandwich where we had the dead crow on the bottom, and then you had the first mate come in and attempt to copulate with the dead crow, and then you had the second mate get on top of its partner and either attempt to copulate with its partner or the dead crow. That part is unclear. You also then saw a third bird come in and start pecking really violently at the dead crow. You also saw one of the birds that copulated eventually do that. And so we have a lot going on, right? We have some fear behaviors and alarm calling. We have some sexual behaviors, and then we have some aggressive behaviors. And the first time we saw this, we were just like, what? What are they doing? And this particular behavior, so after we saw this the first time, we made a real effort to try and quantify it, right? Because the question is, well, is this just a weird one-off? There was some wild thing that happened, so they reacted really strangely, or is this maybe a normal part of how they respond? And we found that particular behavior where you have multiple crows and a mated pair attempting to copulate, extremely rare. We only saw that one other time. Sexual behavior, just generally though, we saw about 4% of the time. But then some kind of tactile contact, whether that was aggressive pecking or just kind of gentle, sort of looking, trying to pull out a feather. That we saw about 30, I think it was 38% of the time. But we only see these behaviors in the spring. Come the end of summer, they never come close to these crows. And that's really interesting because that suggests that this has something to do with the breeding season. And maybe it's that this sort of flush of hormones that they undergo is making them, more prone to not being so good at kind of assessing appropriate reactions. Maybe it's just making them so aggressive and so horny that they're just like, I don't know how to deal with this, so I'm just going to do all the things on my bucket list. We don't really know, but it was a really interesting observation. And so we published that one as well if you want to learn more about that. But really importantly, well, some people might think like, that's so on brand. Crows are so weird and creepy. It's actually really important to understand that those other animals I showed you, that the primates, the elephants, the dolphins, we see those behaviors in all of those animals as well. As it turns out, those kinds of complicated, aggressive sexual reactions, not so uncommon in terms of, they don't represent the majority of the way each of those species respond, but they do occur consistently across all of them. So there's something interesting going on there. And then the last thing we looked at is what's mediating this response. So, crow sees a red-tailed hawk depredating a crow, sees that information goes to its brain, and its brain produces a behavior, right? That kind of scolding behavior. So when I'm out there and the crow's doing this, it kind of looks the same to me, whether it's doing this in response to a red-tailed hawk or a person it doesn't like or a dead crow, it's going and kind of screaming. But that doesn't mean that what's happening in here is exactly the same across those stimuli. And in fact, we know that it's not. And one way that we could potentially maybe get at this question of grief, of is there an emotional response in addition to these other motivators like danger learning, is by trying to identify what parts of the brain are mediating this behavior. So we have a really cool technique that we have utilized in our lab where we capture crows in the wild. We let them acclimate to this aviary, we keep them in. And then when it comes to imaging day, we take them down. We work with a radiologist and a few other folks at the UW hospital. We inject them with a chemical called fluorodeoxyglucose, which is a modified glucose molecule that has it's modified in such a way that the body can't decompose it, and it has a tracer, which that does decompose, attached to it. And so what this allows us to do is the brain, right, as the brain works, it uses energy, it needs sugar, it needs glucose. And so whatever part of the brain is working the hardest is going to use up more of that chemical. And for a frame of reference, that's the same chemical we would give you if you were getting a tumor PET scan or something like that. It just helps light up areas of metabolic activity in the body. And so we can give that injection to an awake crow, an unrestrained crow, and then we can show it something like a dead crow or a red-tailed hawk or a scary person or a person they've never seen before. And the brain is going to look at that information, take it in and process it, right? And it's going to be concentrating that chemical somewhere. Then we can anesthetize the crow, and we have this special CT scanner, PET scanner, that we've modified specifically for the crow body, and then we can detect where that tracer landed. And after about 40 minutes, the crow comes out of the PET scanner, wakes up, we give it 24 hours in the lab to just, recover, and then we let them go. And this is one of the really rare cases in brain work in animals where we don't have to euthanize them ultimately. So it's our best way to ask questions of sort of neurology and brain function in as least invasive way as we possibly can. And what we found is, again, crows do use different parts of their brain to process that kind of information. We have not found the amygdala is the part of the brain we would expect to be most active if they were having a strong emotive response. I mean, we've been able to show that in people and other animals using MRIs. And if you're wondering why we don't use MRIs and we're using PET scanners, which are sort of less familiar tools, it's because if you go in an MRI to have your brain imaged, you have to be awake. We can't put an awake crow in an MRI because that would be incredibly traumatic and their whole brain would just be like, it would not tell us any information. So we use this kind of retroactive method so that when the crow is restrained, it's not awake, it's asleep. And we haven't found any evidence that the amygdala is active. In fact, the part of the brain that we see most active when they are looking at a dead crow is actually their analog to the prefrontal cortex, to the decision-making part of their brain, which in retrospect makes sense, right? Because we saw from these other experiments I did that they can do a variety of things depending on the information. So they're clearly processing and thinking about these things. And then the last piece, I know we're getting to the end of our time, that I kind of just want to end with is, I hope at this point you've been convinced that these birds are amazing. They do interesting things, they're so smart, and so they're really fun to watch. But to me, really the best part of engaging with that relationship is that it's a two-way relationship, right? It's not just putting out a bird feeder and enjoying the birds that come and checking them off of your list and then saying goodbye. These are birds that really watch you back. And I mean that in the least creepy way possible. It's just a really fun opportunity. And, you know, I took this picture a few years ago on the UW campus, and to me, it's so symbolic of our relationship with crows, because it's a little bit hard to see, but on top of this statue are bird spikes, right? Where our maintenance team has tried their very best to prevent this exact thing from happening. And yet here the crows are really building their worlds on our backs, whether we like it or not. And so crows are kind of one of those things I say, you know, you're not going to beat them, so you should join them. And there's some really fun things in store for you if you do. And a big part of that is that crows can learn and recognize our faces. And they can do that in negative contexts, like here. If you've ever thrown a rock or picked up a fledgling or something like that, they'll remember you and they might go after you a little bit. But there's also the alternative to that. If you form a positive relationship with them by offering a little tiny bit of food every day, you can have really wonderful interactions. And one of the byproducts of that can sometimes be gift giving. So I will end with this story. There was a gentleman who lived outside of Seattle that fed crows every day, and he had this platform style feeder outside of his house. And one day, you know, he'd bring them leftovers or whatever. One day he was feeling a little cross, and so he put the food out and he said, you know what, every day I bring you guys these treats and you never return the favor. And went back inside, and half an hour later, whatever it was, he went out to just make sure they cleaned everything up. And he saw that the food was gone, but in its place was one of those little candy Valentine hearts that said love on it. And he was like, oh no, I've lost it. What's going on? And so he reached out to John Marsliff, who was my PI when I was a graduate student, and said, I'm worried you're not going to believe me, but this happened to me. I need you to explain. Am I losing it? Like, tell me what's going on. And so John went out and interviewed him, and, you know, he came up, as being the scientist, he came up with his hypotheses. You know, maybe the guy made it up. Maybe somebody pulled a prank on him. They were trying to make him believe this, but they actually orchestrated it. Maybe crows understand written and, you know, oral human language, and we're all screwed because they're going to take over soon. Or maybe it's something else. So after talking to him, it became very clear that he believed this really happened. He did not make this story up. It also became clear that no one was pranking him. His wife had mobility restrictions, so she couldn't get out to the platform. His kids were out of the house, and his neighbors, as do many, hated that he fed the crows. So they weren't going to play like this whimsical prank on him. So we can rule out those two hypotheses, and that leaves, you know, that crows just understand us, which crows are very smart, but I don't think we're there yet, or that we just don't know the answer. And that's kind of where we're at. So this gift-giving behavior has been pretty widely experienced. Whether they're actually gestures of gratitude or whether crows are capable of experiencing gratitude, we don't know. I think it's possible it's kind of an accident that then gets reinforced, the way that a dog, you know, sitting for a food treat is maybe an accident the first time because you kind of tease them into the behavior, and then they're like, oh, this works. But, you know, I don't actually know. And in the meantime, it's really fun to have this experience. So with that, I will wrap things up. If you want to contact me beyond this talk, these are the best resources to do that. And I would happily take some questions if there's time for that.
Yeah. So Dr. Swift, that was incredible. But there are a couple things that really made me laugh. When you talked about a crow subculture, I thought, I didn't know there was such a thing, but I think you've gotten several of us to join the crow subculture right away. You also mentioned crows versus ravens, and I kind of see that happening with pigeons versus doves. There's not a really fine, there's not really a firm line between those two, but it does happen all the time.
Yeah.
Um, and it's so nice that you brought up Rosemary Moscow. She's actually going to be appearing at Speaker Series in 2 weeks.
Hey, that's so
So
exciting.
yeah,
No,
we're
she's
thrilled.
awesome. She's just a
Well, we're
great
thrilled
person.
too. So you can log in if you'd like and see her. I bet she'd be really surprised to see you.
Yeah, yeah, that'd be really fun. I hope you send me the link.
But our neighbors, I know there are going to be some questions, but I have a couple I want to get out just before we read the other questions. But our neighbors put out their garbage just like we do every Thursday. And I've noticed that there are a pair of crows that come to visit their garbage only, their trash can only, because it's usually got a little bit of an opening. It's broken, so the top is opened a bit. But then I noticed the other day that they showed up before the trash cans had been put out. So it seems like they must have learned that. And I sort of took note of that, and I thought, well, possibly they learned that the schedule is just about time. But what I learned tonight is that this is probably the same pair that we've seen year after year after year. So that's really fun. So they're learning, and we're learning too by watching them.
Yeah,
Um,
absolutely.
and my wife and I have been to Australia, and we saw a bunch of crows and ravens there, and they've all got white irises. And I'm wondering if there's any sort of wisdom about why it is that the ones in Australia have got white irises and the ones in the rest of the world have dark.
Yeah, I don't know the answer to why the Australian corvids have. Yeah, it's like an ice blue, almost white iris, like you said. The Caribbean crows, many of them have red irises actually. So it's kind of
Mm-hmm.
blue, red, and then that white color that are the most common, or that we see represented. And no, I can't offer anything other than that everything is backwards in Australia. Toilets and the eye color. So
That's for sure. That's for sure. Well, also the other thing that would make me really laugh is putting necrophilia on one's bucket list. That
yeah.
was pretty funny. One last thing, and then I think maybe Carolyn or Barry would be able to read through some of the questions that have been coming in through the chat. But the most common question that we get at the Audubon Society is, and I can't tell you how many times that I've answered this each fall and winter, is about the huge flocks of crows that people get in their neighborhoods. And the questions vary between, why are they here? When are they leaving? What does this mean? Is there some way that I can get rid of them? And my reaction is always, well, just appreciate them. It's nature, and this is a phenomenon. It'll in a couple of years they'll choose another roost. What would you say to those folks?
Yeah, I think so we have two really enormous, 15,000 plus bird roosts. We have two in Seattle on kind of either side of the city. And I encourage people, we watch nature documentaries, we see the flight of the monarchs or the migration of the caribou or the wildebeest. And I think anyone who's interested in nature sees that and just goes, wow, like I wish I could go and see some kind of spectacular animal movement. And communal roosting, which is what that behavior is. So crows, maintain these territories, but at night they get together in these social groups to sleep. And those roosts can be enormous. Historically in the United States, the biggest documented roosts were 300,000 birds. And so we have an opportunity here without necessarily traveling even outside of our homes to witness an amazing movement of animals. So I completely validate and agree with your sentiment of appreciating it as an opportunity rather than sort of being troubled by it or
Yeah.
resenting it because of the noise or whatever. It's really just a very cool opportunity to see these animals and see what it looks like to be in those kind of big social groups. And it is the reason that behavior ticks up in the fall and winter is because, of course, in the spring and summer, birds stay on their territory all day and night because they're incubating eggs, so they're on eggs at night or they're brooding nestlings or whatever it is. And so that's why we see that behavior change seasonally.
I don't know if you've been to Yuba City in California, but we would go there every winter in an overnight trip to prepare for a gray lodge visit the following morning. And at night, we would see thousands of crows gathering in the, I think there were willow trees, kind of nubby willow trees that were planted along a main road in Yuba City. There were tens of thousands, it seemed. And year after year, we would see them, and it was something we could count on. But the last time we went there, just my wife and I by ourselves, we didn't see them in winter. And it was just a curious kind of sad thing. But they must have chosen another roost.
Yeah, the roosts do move, and that's not uncommon. That's not always by force. Sometimes it is, right? Sometimes we degrade roosting habitats in ways that it encourages them to disperse, but sometimes they also just find spaces that they like better. The vegetation develops in such a way that they find it preferable. So yeah, that could be a sad thing or not.
Yeah. Well, I'm going to stop talking because Carolyn is telling me that we have lots of questions coming in. So Carolyn, why don't you go ahead and start giving Dr. Swift some questions?
Yeah. So one of the questions we had at the very start of your presentation was, do crows soak their food for the same reasons that raccoons do?
So crows soak their food for water. So it's just a good source of water. Particularly, you'll see that behavior a lot right now because that's exclusively how nestlings get water, is through food. And it also just often softens it. You know, if they're pulling out really crusty old crap from the garbage bin, it might be a little hard to tear apart, but if they get a nice soak on it, then they can rip it up. Because crows, you know, they're big birds, but they're not that powerful in terms of, you know, they're not carrion specialists. And so crows can't break the skin of any mammal really bigger than a rat. They can go in through, you know, soft parts like the eyes and the anus, but apart from that, they really are not that good at kind of ripping into things. And so, so water is a really useful tool for them.
Awesome. Another question is, does the crow response differ if they can recognize the individual dead or injured crow? So if they're familiar with the individual?
Yeah, that's a great question. So we didn't test that. We used exclusively unfamiliar crows. So there's a big question, you know, if they had been ones that they knew, would we see that the response was really different, particularly in that imaging study? And I think that's totally possible. I think it's possible it's not actually that different, because ultimately we kind of have to ask, you know, would it be adaptive for them? You know, what would motivate them to have a different response if they knew it or didn't? And so, you know, having this really, for example, if they grieved for a really long time, if they lost their young, if they saw their own dead infant rather than another one, the disadvantage to that is, you know, discourage them from moving on and making a new brood. And so, yeah, there's a lot of interesting ways that we could think about that and potentially explain it, but we don't know the answer yet.
Awesome. So one of our watchers made a point that our local crows do some cooperative breeding, but the ravens don't. Florida scrub jays do, while our scrub jays really don't. So is there some common ecological driver that supports cooperative breeding?
So that's kind of a $1 million question. One explanation is it has to do with resource availability. So if young are unable to disperse because there's a really limited number of territories, for example, then it's to their advantage to stay on their natal territory for as long as possible, so that when they do disperse, they're in the best position to be successful. So with those species, it may not be in any way to their advantage to stick around, because if they disperse right away, they actually are more successful breeders in the long run. But that's kind of ultimately what it comes down to. And there might be a variety of things that feed into those pressures and things shaping those evolutionary trajectories.
Nice. We've got one last question. So is the crow behavior and communication consistent wherever they're found, or are there distinct regional differences?
No, there can be really distinct regional differences. And that's one of the tricky things with, you know, American crows being the ubiquitous species across the United States is, I'm talking from a Pacific Northwest perspective, but there are some ways that they might differ really strongly. So for example, we don't see helping behavior in Seattle, which is the population that I've worked with the most, all that often. It's only in about a quarter of all family groups do we see that. But in places like New York, we see really robust helping behaviors. In Oklahoma, as another example, it's been reported that there's very little territoriality. They seem very chill all year round, versus in Seattle, every year will see or be sent videos of crows killing one another over territory disputes. So yes, there are very distinct regional differences, and those are rarely really captured in the literature. We often just say crows do this, and we don't say where those crows, where we learned that, were living. So you do kind of have to be a little careful.
Awesome. I'm not seeing any further questions in the chat, but if anybody who's still on.
Well, I wonder, Kaeli, could you unshare your screen?
Yes.
So that was a fantastic talk. Thank you so much. The research you've done and what you've told us is just amazingly interesting. So I wanted to thank you for that. But I also I had asked at the very beginning if people had a thought about how many corvids we had in our state and in our county. And rather than going through any answers, I just thought I would let you know that we've got 10 species of corvids in California, with an occasional 11th. So we've got American crow, common raven, yellow-billed magpie, black-billed magpie, California scrub jay, island scrub jay, Steller's jay, Canada jay, pinion jay, and Clark's nutcracker. And in our county alone, Santa Clara County, we have a total of 5 that are typically here, plus an additional 3, very rare, including pinion, which is, I think, one of the only corvids that doesn't have the bristles over the nostrils. In fact, I think it's part of its Latin name, refers to the fact that it doesn't have the bristles over the nose. But we are in this county and in this state uniquely qualified to enjoy the corvids. There are so many species. We're blessed with so many more than some of the other states. So your presentation tonight really helped us appreciate that, and I want to thank you again for spending time with us this evening. And if you're free in 2 weeks from tonight, you can join us, and Rosemary will be here to talk about her work. So looking forward to it. I hope everybody enjoyed your evening with Dr. Kaeli Swift and her incredible research. Thank you from Audubon Society, and thank you, Kaeli. I look forward to seeing you again sometime. And with that, I guess we'll say goodnight to everybody. Everybody have a wonderful evening. I had my camera off, I apologize. So good night, everybody. Thank you so much, and I hope to see you again soon.
Thank you so much, everyone.
Thank you.
Bye-bye.
Stay safe, stay healthy.
Thanks and good night.
Bye.
Thank you.
Yeah.
Great
Bye.
talk.
Too.